Section 8.1. In this section, we're going to be defining and using sequences and series. Okay, so our objective for this lesson, I broke this section up into two parts. This first part is we're just going to use sequence notation to write terms of sequences. And then we want to write a rule for the nth term of a sequence. So before we can get into those objectives, we need to talk about what a sequence is first. What is a sequence? A sequence is just an ordered list of numbers. Okay. It is an ordered list of numbers. Okay. For example, 1, 2, 3, 4, ... on forever is a sequence. Okay, that's our most basic sequence. It's our counting sequence. It's a sequence of the whole numbers. Okay, we call the first thing in our sequence, we call each of these numbers terms. We call them terms. And so this one would be the first term, and then the second term, and then the third term, and then so on. Okay, so each of these is called a term. If the sequence does not end, like in this case it does not end, we put the ... after it, we call it an infinite sequence. Okay, so infinite does not end. Okay. Okay. Our terms we tend to list as a sub 1, a sub 2, or n sub 1, n sub 2, depending on how we're doing it. We normally go a sub 1, comma, a sub 2, comma, a sub 3, comma, a sub 4, okay, and ... So this marks the first term, the second term. These are what we call subscripts. They are down below, they're small numbers, down to the right of the actual A. Okay, so they're subscripts, so they need to be written small and down below and to the right. Okay, a sequence that stops is what we call a finite one. For example, if I was just looking at the numbers 2, 4, 6, and 8 and ended there, okay, if I just ended there, that's what we call a finite sequence because it has an end. It's just those 4 terms. Okay. We can simplify, we can actually talk about a sequence by a rule. When I say rule, what I'm meaning is an equation. And how we want this equation to work is when I put in a 1, I get out the first term. When I put out a 2, I get the second term. And so on. When I get out a 3, I get out the third term. Okay? So, and how we'd write that, we can either write it in sequence notation or in function notation. Okay, for this one here, the 1, 2, 3, 4, my rule would be my a sub n is equal to just n. Because the first term, when I put in a 1, I get out a 1. The second term is a 2. The third term is a 3. The fourth term is a 4. And so on. So a sub n equals n. Or I could write it as a function. F of n equals n. That's our most basic of functions. Okay. But if we look at our finite one here, let's look at this one here. Let's write a rule for this one. My a sub n, I always line up, this is my first term, my second term, my third term, my fourth term. I'll always look, how do I get from 1 to 2? How do I get from 2 to 4? How do I get from 3 to 6? How do I get from 4 to 8? So I'd multiply by 2 each time. 2 times 2 is 4, 3 times 2 is 6. So my rule is 2 times n. Because the fourth term, when I put a 4 in there, 2 times 4 is 8. The fourth term is 8. The third term, when I put a 3 in here, 2 times 3 is 6. The third term is 6. Okay. Again, we could write it as a function. Okay. Right, so there's 2 basic types of sequences. There's an arithmetic sequence, or it's called arithmetic, depending on how you pronounce it. So we have our arithmetic sequence. Okay, an arithmetic one is where it increases by the same amount each time. Like in this one, it increases by 2 each time. So there's a common difference. Okay. So let's look at this one right here, and let's continue this one out for a bit. Let's have it 8, 10, we'll go to 12. Okay. So here, if I was to graph this this is an arithmetic sequence because the common difference is always 2. It's always going up by 2. So let's go ahead and let's list that one. So we got 2, 4, 6, 8, 10, and 12. That's an example. So there's an example right there of an arithmetic sequence. So to graph this, the first term, so when I put in a 1, my first term is 2. My second term, when I put in a 2, I get out 4. 1, 2, 3, 4. My third term is 6. 1, 2, 3, 4, 5 is 6. So if you notice, what this is going to do is this is going to graph a line. Okay, so it graphs a line. Since it graphs a line, we can use our linear algebra to write my rule. Use linear algebra to write a rule. Okay. So meaning what I use is I can use the y equals mx plus b, or the y minus y1 equals mx minus x1 to write my rule. But again, then I'd have to write it in a sequence form, a sub n equals, and use that n notation. But I can use these tools to help me write them, okay, because it ends up graphing a nice line. Okay. All right, so that's an arithmetic sequence, or arithmetic on how you want to pronounce it, okay? The other type is a geometric. This is one where it doesn't go up by a common difference each time. It doesn't go by the same amount. It goes up by a certain percent each time. Okay. For example, let's look at 2, 4, 8, 16, 32, ... And again, an arithmetic could be both finite or infinite. Could be both. Okay, you could have a finite arithmetic sequence if this stopped here at 12, or you could have an infinite one where it keeps on going. Same with geometric. You could have a finite one, let's say if we just stopped at the 16, or we could have an infinite where it keeps on going. Okay, if you notice here, if I subtract each time, I'm not getting the same difference. Okay, but if I divide, okay, if I look at that common ratio, 4 divided by 2 is 2. 8 divided by 4 is 2. 16 divided by 8 is 2. 32 divided by 16 is 2. So there's actually that common ratio. And if you remember back to when we talked about this common ratio idea, when we had a common ratio, that meant what? It graphed an exponential. It's an exponential equation. So, and then how to graph this, the first term is 2, so when I put in a 1, I get out a 2. Second term is 4, so when I put in a 2, I get out a 1, 2, 3, 4. Now, here's where we stop getting linear. When I put in a 3, I get out an 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So you think about when I put in a 1, I get out a 2. When I put in a 2, I get out a 4. When I put in a 3, I get out an 8. When I put in a 4, I get out a 16, and so on. So if we were to write a rule for this one, my rule, if you notice, would be going to be exponential. My base is 2, so it would be 2 to the n. Okay. Because we keep going up. Now let's double check it. When I put in a 1, I get out a 2. When I put in a 2, I get out a 4. When I put in a 3, 2 to the third is 8. When you put in a 4, 2 to the fourth is 16, and so forth. So you can always check your rule. So it's exponential. So it'll have an exponential equation. Hey, and we can actually use our calculator to help us find these rules, because I can do a linear regression to find an arithmetic one, and I can use an exponential regression to find my geometric. But first I have to decide which one is it. So first you have to look at both the common differences and the common ratios. Let's go ahead, let's jump around a bit and find a couple of these. We're going to first identify them as arithmetic or geometric, and then we're going to write a rule for them, and then find the 10th term. Okay, so first let's look at the common difference. So let's see if the common difference holds. So we're going to look at the common difference in this case. So let's subtract the 2. So if I take 2.5 minus 1, that's 1.5. Okay, so I'm just subtracting. So let's take 4 minus 2.5. That's 1.5. 5.5 minus 4 is 1.5. So it looks like the common difference whole. So that tells me that this is an arithmetic sequence. It's an arithmetic one. Okay, so now we want to write a rule for the sequence. Okay, meaning when I put in a 1, I get out a 1. When I put in a 2, I get out a 2.5. When I put in a 3, I get out a 4. When I put in a 4, meaning to find the first term, I would put in a 1 and it would give me that. When I would find the second term, I put in a 2 and it'd give me that, and so forth. So there's a couple different ways of finding this. One way is to plot these points and to write the equation. So we can go ahead and we can plot these points in our calculator, or we can do them on graph paper. Maybe graph paper might be a good idea on this one. Well, here, we'll just go ahead and let's sketch, okay? Because this isn't very big. So we put in a 1, we get out a 1. Put out a 2, we get out a 1, 2.5. Put in a 3, 1, 2, 3, we get out a 1, 2, 3, 4. Okay. So there's our linear equation. Okay. So it looks like my slope is up 1.5 because I'm going to go up 1.5 and over 1 each time. So my slope, m, is 1.5. Now where do I start? So let's go ahead and let's back up from a 1 because I want to know my y-intercept, so I can use this form. Y equals mx plus b, we know my m, I just need to find my b. So if I'm at 1, if I go down 1 over 1 and down 1.5, because that's my slope, 1.5, we're going backwards, we'd be here at negative 0.5, I believe. So my y-intercept, and if I sketched it appropriately, is at negative 0.5. So that's my b value, there's my b. So my equation, my y equals mx plus b then, would be y equals my m, 1.5x minus 0.5. But again, we want to write that as a sequence. So a sub n equals 1.5n minus 0.5. Now let's double check it and make sure it works. We can graph it. 0.5x minus 0.5. And now let's try our points. When I put in a 1, we get out 1. When I put in a 2, when I put in a 3, we get out a 4. When I put in a 4, we get out a 5.5. Okay, so sixth term. Now we want to find the seventh term. It says find a sub 10. So my a sub 10 would be my 10th term, then would be 14.5. What's great is once you have the rule, I don't need to find, here's the 4th term, 5th term. I don't need to find the 6th, 7th, 8th, 9th to be able to find the 10th. I can just plug it into the equation and know what that 10th term is going to be. So if I wanted to know the 50th term, boy, it would be a lot of work to find the 5th, 6th, 7th, 8th, 9th, 10th, all the way up to 50. Whereas once I have my rule, I can just plug a 50 in, 74.5. Okay. All right, let's go ahead and let's look at another one. Let's jump around a bit. How about let's go to F? Okay. Let's go to F here. Let's see, does this fit? Is it an arithmetic one or a geometric one? So we're looking for common difference or common ratio. So common difference, well, if we take the 4 minus the 8, that's negative 4. 2 minus 4, okay, that's not working. So it's not a common difference, let's find a common ratio. Let's take the previous and divide it by that. So 4 divided by 8 is a half. 2 divided by 4 is, 2 divided by 4. 2 divided by 4 is a half. 1 divided by 2 is a half. 1 half divided by 1 is a half. So it looks like here we have a common ratio, which is going to make this a geometric sequence. Okay. Now we need to find the rule. Okay. So let's see, when I put in a 1, we get out a 8. When we put in a 2, we want to get out a 4. 3, 2, 4, and 5, so forth. So, if we look at our rules here, what when I put in a 1, again, it's exponential. So when we put in a 1, we're going to get out 8. Put in a 2, we want to get out a 4. So we'll probably need to write some exponential, or we could try graphing it, Or we could try our calculator. We're just trying to find a rule here. So a lot of options are guess and check. Let's go ahead, let's try our calculator, see if our calculator can give us any useful information. Let's plot the points. 1, 2, 1, 2, 3, 4, 5. Get an 8, a 4, a 2, a 1, and a 1/2. So let's plot them and see if it's any help. Okay, so let's plot them, turn the plots on. Plot 1, remember how to turn the plots on, I just went up here and turned them on. And then I'm going to go zoom stat. So there it is, it looks like an exponential decay. So now we need to write an equation for it. Okay, all right, so let's go ahead and let's see, how do we write an equation for exponential decay? Do you guys remember? How do we do that? Well, we could trial and error. Trace. We could, that might be something we need to look up. So that's one thing I want you to do. I want you to research, look through your notes, anything previous we've done, how to write an equation for this. And maybe using your calculator. How do I write an equation that fits these data points? Okay, come to class ready to share out on that.